Welcome to this video lecture on the topic antenna fundamentals. So in this we are going to discuss about the fundamental parameters of antenna. So first, antenna background, where Maxwell derived the fundamental equations called as Maxwell's equation for the understanding the electromagnetic wave propagation. And next, Hertz proved the Maxwell equation. So first aerial propagation is done in his period, and Marconi done the transatlantic transmission using radio waves. So what is an antenna? An antenna is a way of converting the guided waves present in the waveguide, feeder cable or transmission line into radiating waves traveling in free space. So it converts the electrical signal into electromagnetic waves. So it is a passive structure, serves as the transition between a transmission line and air, used to transmit and receive the electromagnetic waves. So it converts electrons to photons of electromagnetic energy. It is a transducer which interfaces a circuit and free space. So here the transmitting antenna and receiving antenna are illustrated. So only accelerated or deaccelerated charges radiate electromagnetic waves. So a current with a time harmonic variation, AC current, satisfies this requirement. So generator or transmitter is used, and the electromagnetic wave is guided wave is transmitted to transmission line, and a transition region is the antenna, and free space wave radiating in all the three dimensions. And similarly at the receiving antenna, plane wave is received and it is given to the guided wave to the receiver. The role of antennas. Antenna serves four primary functions: spatial filter, polarization filter, impedance transformer, and propagation mode adapter. So the types of antennas. So we have many types of antennas are there, in which the end-fire antennas, loop antennas, dipole antennas, and slot antennas, aperture antennas. These are most used antennas. Isotropic antenna. So what is an isotropic antenna is? It is an hypothetical antenna. It does not exist in real life. It is used as a measuring for real antenna characteristic. So it is the measuring bar acts as the reference antenna, and it is a point source that occupies a negligible space. It has no directional preference. The pattern is simply a sphere, so it has the beam area, it is equal to 4 pi radians. Isotropic radiator is a hypothetical lossless antenna having equal radiation in all directions. And other antennas are omnidirectional radiator and directional radiator, where omnidirectional radiator having an essentially non-directional pattern in a given plane, and directional radiator is having the property of radiating or receiving more effectively in some directions than the others. Usually the maximum directivity is significantly greater than that of the half-wave dipole. Spherical coordinates. Here the spherical coordinate is used for analyzing the antenna structure, where the phi is the azimuthal angle. So it is used in spherical coordinates, and theta is used for elevation. And as shown in this diagram, there are three parameters: r, theta, and then phi. Solid angle. One steradian is the solid angle with this vertex at the center of the sphere, as shown in this diagram. Sphere of radius r is taken, which is subtended by a spherical surface of area r squared. So there are 4 pi steradians. So this is used for measuring the radiation intensity of an antenna. So radiation intensity in a given direction is the power per unit solid angle radiated in this direction by the antenna. So radiation pattern, it is a three-dimensional graphical representation of the far-field radiation properties of an antenna as a function of space coordinates. The far-field region is enough for the radiation pattern to be independent of distance from the antenna. So it is measured using the two planes, one is E plane and H plane. Either field pattern is used or power pattern can be used. So these are the radiation pattern characteristics. So here the 3 dB bandwidth or half power bandwidth is used, and the side lobes and these are the parameters in the radiation pattern characteristics: nulls front to back ratio, gain, and maximum signal position. So here the radiation pattern is explained using the main lobes and other parameters. Main lobe is the major lobe consisting of the maximum radiated intensity in a particular direction. So it covers the radiation emitted from the antenna. So it is the major lobe, and the back lobe is the radiation in the opposite direction, and half power beamwidth is the angle between the two half power points, and first null beamwidth is the angle between the two nulls, and side lobes are the minor lobes which are minimum radiation in other direction and is their directions. So these are the antenna pattern parameters. Assessment questions. Units of radiation intensity, as we discussed, it is watts per unit solid angle, and radiation lobe containing the direction of maximum radiation is called as